Hi there, welcome to the RPS project. Today I'm going to have a look at the Wien Bridge Oscillator. I'm quite sure how you pronounce it, but I tend to say Wien Bridge Oscillator. It's a little oscillator circuit that's been around for decades, apparently a long time, developed a long time ago, and can be a really stable little oscillator. Now, I had a look at this oscillator circuit quite a number of years ago and came up with this little thing. Didn't really work quite well. I didn't quite understand the circuit or what was going on with it, so I decided to come back to the oscillator and have another look at it and see if I can understand it better. So let's start off with the whiteboard and then we'll have a look at it in operation. So here we have the circuit on the whiteboard. Now, I think this is quite a simple circuit now that I understand it, but it took me a while. But the basics of it is that we've got an op amp and a couple of resistors, and this obviously, like any op amp, sets the amplification, sets the feedback and how this is going to work. R1, C1, R2, C2. Now these two sets of resistors and capacitors, they set up the frequency apparently, and that seems to work quite well. Now with this circuit, R1 and R2 are the same, C1 and C2 are the same, and so if they're all equal, then that's how it works, and there are calculations to work out the frequency, and that all works very merrily. Now the trick to getting this to work is apparently to get R3 and R4 working correctly. Now R4 from my list here, as you can see, is that I've used a pot for R4. Like so. So I can actually travel along the whole length of that 10k. Now the other thing about this circuit to make it work is that the R4 needs to be half, around about, of R3, or as I've seen it written, R4 equal to or less than 2 R3. So that's what you need to be able to help this circuit set up so that when it oscillates, the oscillation doesn't run away with itself, or the oscillation is too small for it to actually create a feedback that this can then feedback to create that feedback properly. Otherwise it just diminishes and disappears, or if it's too much you get a lot of distortion, it goes over the top and it all looks horrible. But that is the circuit. Just put that on there because you do need to have really a proper split rail, positive and negative. So even though I put that at 0 volts, they're coming, the R4 and the capacitor resistor circuit is actually coming into what I'm calling the common from this op amp that I've set up to give me that positive and negative sort of circuit. There we go. It seems quite simple, so I suppose better have a look at the actual circuit in action. Okay, so here we have the circuit, well, or at least the old circuit. Now this is the one that I made a number of years ago. I just found the circuit on YouTube and on the internet, and I thought, well, that'll be fine, I'll just copy it and make it up on this breadboard. And oddly enough, that circuit had a little bulb on it. Now back in the early days, Mr. Hewlett and Mr. Packard made a oscillator circuit from this Wien Bridge Oscillator, and they put a bulb in it. I thought, well, I don't have a bulb, so I'm just going to use a fuse. Now this fuse is one of those little ones you get in the digital multimeters, you know, like 200 milliamps, and you know, it seems to work, or at least I thought it seemed to work. So I suppose I better connect the scope up onto it and have a look at actually what this one gives me, and then I'm going to move on to this one, which is my new circuit, which actually does work. So let's have a look at what these give us. Okay, so I've got the scope turned on, and nice trace, 2 volts per division, 500 microseconds. I suppose that should be okay. Hopefully it will. So I'll turn this on. Now this is the old circuit that I'd made years ago, and well, there you go. I've actually got some out, but it looks more like a square wave than a sine wave. So basically, I've not got the that feedback right, have I? You know, it's not as it should be, and the two pots that are in there don't really do a great deal. If anything, they just adjust the frequency, which is no use to me at all. I want to be able to adjust that feedback loop so that I get a good solid sine wave signal, not this basically over the top signal which is chopping off top and bottom. So that's no good to me at all. So let's plug in the other circuit and see what I get. Okay, so I've now hooked up to my other circuit. I'm just going to turn it on, and then I'm going to turn that pot up until I get a signal, because basically I'm trying to get about half of R3. This is R4, the pot's in position for R4, so hopefully as I turn this pot at some point I will get a signal. Where is that signal coming through? Keep on going. Ah, there it is. Ooh, that was twitchy. Look, it's already slightly distorted, so let's try and turn that down, see if I can get it neater. Oh, and it's disappeared. Oh, this is twitchy, very twitchy. So as soon as it comes in, there we go. If I turn it up any more than that, it'll be distorted. So as soon as it starts, it's a slight clipping on the bottom here even now. So as soon as it signal comes in with the right feedback required on that op amp, you get this nice sine wave. Quite a good voltage on there as well, but it's already trying to clip. So I mean, as soon as you start turning this up past that, you really can, you know, clip that that circuit. But as soon as you turn it down just a little bit too far, it disappears. So trying to get a nice sine wave is really hard, because it's right on the edge of that op amp giving the appropriate feedback on that feedback loop to make this sine wave nice. I suppose if you mess about with the circuit and work on it, then you can get that sine wave to be nice and clean and to be really stable. But well, yeah, there you go. With the circuit I used that I drew out on the whiteboard, that's what you can get, rather than that horrible mess I'd got from years before. Seems to work to me. So there you have it, the Wien Bridge Oscillator. A very simple circuit. Well, it seemed quite simple to me. Fairly straightforward once I'd got to know it. I mean, as I said before, I did have a look at this circuit quite a number of years ago, but didn't understand it, didn't understand the maths or the circuit. I just built what I've seen and had a go. Didn't work very well, but now I've had time to have a look at the maths and to understand what the circuit is doing and to calculate what I do need in the way of components, and it's not too bad. Now, even though I haven't gone through the maths myself, there are plenty of videos out there that do go through the maths, and some of them quite thoroughly. So have a search on YouTube land, and I'm sure you'll find some really good videos on the maths that's needed to understand this circuit. But then really it's not particularly difficult really once you get into it. So you know, it's really quite an enjoyable little circuit. What more can I say about it than that? Anyway, if you liked this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.